Okay, so I am Rob Williams. I'll be talking about the HDMI section first, and then I'll be passing over to Shadid to talk about Bluetooth. I would ask everybody to wait until the end to ask any questions, and when we do have the questions, to line up at the mic and ask. So, HDMI, the high-definition multimedia interface, it's for connecting audio and video peripherals to devices. So you could be plugging in projectors. So a second ago you saw me practicing with my Playbook and my DevAlpha device, television monitors, recorders, home theater systems, and adapters. They're quite expensive, but you can get adapters that are active devices that will decode the HDMI signal and output VGA, so you can be using your legacy devices. HDMI itself, historically, designed in 2002. It was founded by Hitachi, Matsushita Industries, which is Panasonic, Philips, Silicon Image, Sony, RCA, and Toshiba. That's a huge group of companies. It is electrically backwards compatible with DVI, but DVI supports video only. HDMI added audio. It can carry one video channel and 8 channels of uncompressed audio. It can also carry compressed audio. I'd like to quickly talk about some of the features the Blackberry 10 supports in relation to HDMI. It is 1.4 certified. However, several parts of 1.4 are optional. So you can be certified and not implement absolutely every last detail. Of note, we don't support 3D output. And there'll be people who may have seen 3D demos before. And that's because you don't have to be outputting a HDMI 3D signal for a TV to be displaying 3D. So in the background there, Roberto Speranza from our team, this is an image he took of a cactus garden in 3D, and that's how it would be transmitted to some 3D TVs with the left image at the top, the right image at the bottom, and then it's the TV's job to interweave them. And in the other image, we can see that he's got the polarized glasses coming up to resolve it into one image. So you could be doing stuff like that. Another feature that we don't support of note is audio return. When you plug your sound system decoder into your television, even though it's normally the HDMI destination, it can send the audio of what you are receiving to the other end. So you could be playing back your TV's audio through your box. We don't support that. Now here are the settings. They got a lot easier in Blackberry 10 compared to Playbook. You will notice here, over at the left, when there's nothing plugged in, HDMI mode, grayed out. Okay, that's nice and simple. Then when you do plug something in, you get lots of choices. You'll notice here that the mirror mode setting, if you're familiar with Playbook, is gone. The stretching and aspect ratio stuff that was on Playbook is gone. It made things frustrating, harder to use. Something that I've always found odd about mirror mode is it's not a reflection. Which, I don't know, that confuses me, because when it's a mirror mode, you expect it to be backwards. But no, it's more like a duplication mode. And, everything that you're outputting on Blackberry 10 is going to be scaled nicely. So stretched or shrunk, depending on the settings. So if you have asked for a ridiculously high resolution, way higher than the screen, it'll stretch up to that. If you've asked for 640 by 480, it will scale down to that nicely. However, presenter mode is where things get interesting, because you can be displaying distinct content on the HDMI port compared to the screen. And 2 screens are way better than 1. So out in the hall, we've seen people playing games on the Playbooks where exactly the same content is displayed on the Playbook and on the HDMI. For that to happen, you don't have to do anything, because that mirror mode is always there. But here's where it gets exciting. Now, one of the use cases is doing a presentation like this. So if I could put on the HDMI of the Playbook, So here we have a slide coming from my Playbook, which is a duplicate of what was on the PC if nothing looked any different. However, if we can switch now to the ELMO of the Playbook, we see a very different view. Over here, I can be choosing the next slide to jump to or jump back to. Down here, I can be reading my notes. So I can have this Playbook on stage with me, in a meeting with me, or a Blackberry 10 device. I'm using Playbook because the slides to go is on that. You can have your Blackberry 10 device there, totally different content in your lap, on your desk, compared to what everybody else in the room can see. So can we jump back to the slides, please? So these use cases are where actually accessing HMI, for me, HDMI, gets interesting. So you have your assets and your inventory down on the device, and you are just tapping those items. On the remote screen, you get all the details, you get the nice graphics, you get the 3D rotation. Or if you are looking at tabulated data, you have more like a spreadsheet down on your lap, you have an animated graph up on the device. When can we see your cool app? If you guys have done basic screen calls in Playbook or in Blackberry 10, you're only a bunch of lines of code away from having distinct content on HDMI versus local. Just out of interest, who has used the screen headers in Playbook or Blackberry 10? Okay, we've got about 4.5 people. We had one guy waving his hand. That's good. Okay, here comes the deep dive. So this is very much, here's some C code. Everything you will need is in screen.h. You'll be working with screen contexts. Now, a screen context is a context for the entire screen windowing system. It is not a particular screen. A display is related to a particular output. So display is the second thing. That is a particular output. You'll be dealing with windows because you need to put windows on a display. And you'll be dealing with buffers. You have to be buffering the data that you're going to push onto that window somehow. Has anyone here done a Cascades native window sample? Sorry, foreign window. Okay, couple. This is almost exactly the same. When you do that, you need to get the screen, you need to get the windows, you need to get the buffers, you need to be able to display them. So that code, you could change that easily with just a couple of lines to make that come out the other screen. Something worth noting right now is that Cascades won't be managing the HDMI window. You'll be doing everything else low level. Here's how easy it is. You get a screen context, and then you ask it how many displays it has. Normally, you don't bother with that because the 0th display is the device display. Then, once you know how many there are, allocate a little bit of memory and get a reference to all of those displays. Query a display to ask if it is attached. So your code can be sitting there and listening for a HDMI connection. So every now and then, wakes up from a timer, says, is the HDMI screen attached? Yes or no? Is it detached? Because behaving differently upon detach is nice behavior for your app to have. Then, like I mentioned, you want to create a window, which is something that will eventually be displayed on a screen. Assign the window to a display. Then, of course, you can do things like find out how big that is. Because we're going through the settings, choosing the HDMI size, there's got to be a way for your app to know that. There's how you query the size of that display. Then you want to create some buffers for rendering, and then render your content. There are lots of choices. We support BitBlitz, we support OpenGL, lots of other combinations. When you check out the headers as you are allocating those windows and buffers, different constants get passed in to determine how that context will behave. And then post your window onto the screen. This is called Deep Dive for a reason. Now, there is a sample app that is available in our documentation which does this for you. It does a very simple animation, and we're going to try and show it now. So I would like to switch to the ELMO of the ELMO of this. Okay, so there's my Dev Alpha B, just at the home screen. I've downloaded and run this sample. Basically, it draws a blue line. Where's the applause? Okay, so it draws a blue line going across the screen. Now there's no blue line. Can we switch to HDMI, please? Because the blue line is on the other device. So what this sample does is it looks for the screens, looks for the displays, creates windows, and will animate something very kind of boring across those displays. But it's the basis to so many possibilities. If we jump back, oh, too late. If we jump back to the ELMO, we would have seen the blue line had come back. Actually, I would like to jump. Actually, stay on there for a sec. Something that is nice is no other applications on my Dev Alpha are trying to access that display, the HDMI display. So if we switch back to the ELMO, I've actually left that sample app, and I'm now in the web browser. So if we jump back to HDMI, it's still happily going. There's that blue line again. So your content, because it's asked to access HDMI, it's going to be displayed on HDMI, even if the primary screen is now running another app, which, again, opens up some possibilities. This app as well, it's going to go through and detect when you unplug. Can we jump back to the slides? Where'd I put the flicker? Something else that's really important to HDMI is content protection. You should be using content protection if you are displaying content you don't want recorded. So this might be if you are building an application which is displaying protected video. This could be because you are concerned about the safety of your slides. You're concerned that they are corporate secrets. So you could turn on content protection on that connection. And it's supported. You really just have to set two properties, one to protect the buffer and one to enable content protection. And then it's going to be HDCP encrypted out the HDMI port. Thank you. Let's jump over to Shadid.
All right, so since my mic is working, so welcome guys to Bluetooth for Blackberry 10. My name is Shadid Haque. I work in the developer relations team, and one of my focus areas is apps that leverage Bluetooth. So Bluetooth provides amazing peripheral opportunities. If you're a Bluetooth hardware vendor, or if you're just an app developer who leverages Bluetooth, there are opportunities for everybody. Now, before anyone asks why Bluetooth is important, let me tell you that even your shoes have it today. Now, I don't know about you, but I would be freaking out. But now I know, it's not supposed to bite, it's supposed to make your life better. It's a bit of a history before we go down to the details. It's named after a king who was also named Bluetooth. And apparently this guy made diverse communities speak with each other. Apparently they were not talking to each other before. And so does Bluetooth in a way, right? But to be honest, I still think Facebook should be called Bluetooth. So what is Bluetooth? The technology this time, not the king. It's a standard for wireless data exchange. It consumes low power, costs less dollar out of your pocket, but it comes at a price. It has relatively lower data transfer rates, and it also works only over short range. Now, the best part about Bluetooth is that it exposes its functionalities through something called profiles. Profiles are nothing more than a set of rules standardized by the Bluetooth group so that all devices can claim, I follow this profile, so that they can communicate with each other without even knowing each other. Where is it used? I really don't have to say that. It's used almost everywhere. Almost every electronic device today that communicates will probably have Bluetooth. Anything from headsets to Blackberry devices to playbooks, thermometers, heart rate monitor, shoes, all of them have it. So let's dive right into what we have in Blackberry 10 in terms of APIs for Bluetooth. So before we can do anything with a Bluetooth device, the first step is always starts with discovering devices that are around you. And now we're exposing APIs to discover devices programmatically right from your application. To do that, the first step is to call BTDeviceInit with a callback function. This is going to initialize the Bluetooth module, the software module. And once you've done that, you call BTDiskStartInquiry with your inquiry mode. And what that's going to do is it's going to, when it finds a new device, it's going to call back your callback function and provide you with the device it found. Now, please bear with me with the function names. I know they're insanely ugly, but this is an attribute of C. Apparently, it's very cool. But we are working on C++ APIs, and once we have that, it's all going to look like 2012 again. Apart from discovering devices in real time, you can also retrieve cached devices. Cached devices are a list of devices that are found in a previous inquiry. So those devices get cached, and you can get that list really fast without even doing a device inquiry. And there are use cases for it. And to retrieve cached devices, you simply call BTDiskRetrieveDevices with the parameter BTDiscoveryCached, and that will get you an array of the structure type BTRemoteDeviceT. And once you have your remote devices, you can use the BTRDev, I'm going to use the wildcard star APIs to retrieve information about the remote device itself. So now that we have discovered devices, it's time to pair. Without pairing, we cannot connect to any Bluetooth services or profiles. So to do that, we also expose an API so that you can programmatically initiate a pairing process. All you need to do is call BTRDev pair with your RDev object, and the device will automatically show the system user experience that is constant across the device to pair the two devices. And once you call that, what you do is you wait for your callback function to get triggered, and the event you're going to get is BTEVT pairing complete. So if you get that event, you know the pairing is complete. Now you can go ahead and connect to services. But before we go into services, let me show you just a few more APIs that will let you retrieve information about the local device that represents the Bluetooth chip of the Blackberry 10 device itself. And you can also retrieve information about the remote device that you're paired with. And you can get things like friendly name, the address, the class, the type of device, and so on and so forth. Now we're down to business. Let's talk about services. Now you have your device paired. You don't know what services are there. Let's assume that. Sometimes you know what services are there. You can go and connect to that directly. But if you don't know what services are there on the remote device, you can discover services by doing a service discovery. You do that by creating a services array, which is of type string or char pointer, and then you call BTRDEV services with your remote device object. It's going to go ahead and retrieve all the services and return you a list of strings with the service IDs. The service ID is really what you need to connect to a service. Now, taking a few steps back, you can also filter devices by services at the time of discovery. So when you're discovering devices, you can say, I want only those devices that has this service. Of course, you need to provide the service ID in that case. Now, we discovered services, and their service and profiles can be sort of used interchangeably when it comes to Bluetooth. And there are a whole bunch of profiles that are supported on Blackberry 10, but there are only few where an API makes sense. Serial port profile is one of them. So in Blackberry 10, we're going to have a full support for serial port profile, and what it is really a client-server protocol that allows two Bluetooth devices to communicate with each other over a serial port. And these APIs, if you're familiar with the Blackberry Java APIs for serial port profile, they're on par. So that means we support both a client mode and a server mode when it comes to serial port service. Now let's look at serial port client first. Very easy, although the names are still ugly. The first step is to initialize the serial port module itself. To do that, you call BTSPP init, and once you've done that, you open a serial port connection with a remote device. And to do that, you need to provide the Bluetooth address, so identifying the device, and the service ID of the serial port service. So you provide that. What you get back is a file descriptor. Now, when you have a file descriptor, we know what to do. We can read from it, or we can write to it. Anything we write to it is going to go to the remote device, and anything the remote device sends, we can read them by reading the file descriptor. And reading and writing returns a count telling you how many bytes were actually written or how many bytes were actually read. And once you're done with all this, please make sure you tear down everything by calling BTSPP close with the file descriptor. So it closes the file descriptor first, and then you call BTSPP deinit. That's going to deinitialize the serial port module. On the server side, things are pretty much the same, except for instead of calling BTSPP open, you call BTSPP open server with a name for your service, with an ID for your service, and with a callback function. I'll tell you what the callback function does. The callback function provides you with the file descriptor whenever a client establishes a connection with your server. So once the connection is there, it's going to give you back a file descriptor where you can read and write to it. And everything else remains the same. You have the file descriptor, you call read, you call write, get a count back, and finally you tear down the connection by closing the server with the service UID, and you deinitialize the serial port profile service as well. Now here's what the callback looks like. What it gives you back is the file descriptor. In this case, we're assigning that to mount.ft. So that concludes serial port profile. Now let's move on to object push profile APIs. Object push profile, it's meant for exchanging binary objects such as files, pictures, audio, video, business cards, what have you. Now, we have fully implemented the object push profile, and it is indeed used by the core applications on the Blackberry 10 device. And it supports both sending and receiving files. However, the third-party APIs are a little bit tentative for launch, and once we have that confirmed, we're going to share more details, because I just don't want to show you something that you can't access today, right? But I did want to tell you that we are working on an object push profile API as well, so you can programmatically send and receive files via Bluetooth. Now comes the big one, Bluetooth Low Energy. Now, Bluetooth Low Energy gave birth to a whole array of devices that was not possible before. Its main strength is it's extremely low power. If Bluetooth is low power, Bluetooth Low Energy is ultra low power. You can literally go on for years on a single coin cell battery. Think about how many use cases that can have. I mentioned shoes. I made fun of it, but it's not funny. It's very useful, right? Your shoes can now provide feedback without you worrying about when I have to change the battery. So that makes the use case very valid. It's very good at small intermittent data transfers, and there are two sides to it. So if you're a Bluetooth Low Energy device, you can be a server or you can be a client. Servers, as the name suggests, it serves data about some state of the Bluetooth Low Energy device. Examples of servers, just to make it clear, are shoes, heart rate monitors, thermometers, and there are a whole bunch of other devices as well. As servers, you have several capabilities. You can broadcast message that's not meant for any specific Bluetooth Low Energy device, but it's meant for all Bluetooth Low Energy devices that are sniffing the air. So as a server, you have the capability to do that. You can also notify clients when your state changes. So if your temperature changes, if you're a thermometer, you can notify the clients who subscribed for that event that the temperature has changed. Please read this value. And the server, of course, can serve on-demand requests from the client. So the client can call, read that data whenever it wants, and server has to respond. As a client, you can read broadcast messages. You can subscribe for notifications. You can also request data on demand. It's basically the other side. The Blackberry 10 implementation of Bluetooth Low Energy only does client, because that's where the most use cases are. So we wanted to get it out there as soon as possible. But if you have use cases for being a server of Bluetooth Low Energy, please talk to me. I'll make sure it gets hard internally within RIM's product management. So let's look at how we use the Bluetooth Low Energy APIs. We're going to talk about something called the scanning APIs first. The scanning APIs are basically there for listening for broadcast messages. So remember, the servers can send broadcast messages without even being connected. This is how you do it as a client. So you first set up your callback function. In this case, I'm calling it LE advertisement CB. And instead of just a callback function, you actually put it in a structure because that's what it's going to accept. And the callback provides you with the Bluetooth address where the broadcast is coming from, the data of the broadcast, and the length of the data. So let's look at how we can read or listen for broadcast messages. The first step is to start the Bluetooth Low Energy module by calling BTLE init with your LE callback structure, the structure we just set up in the previous slide. And then you add listeners for specific devices. You want to say, I want to listen for broadcasts from this device or that device, right? You just provide the Bluetooth address to BTLE add scan devices, and after that point on, any broadcast messages from that device will be sent to your callback function. And once you're done, tear down the connection by calling BTLE remove scan device, and also deinitialize the low energy module itself. Now, that's about reading broadcast messages. Now let's move on to something called the generic attribute profile, also known as the GATT profile. The GATT profile is not really a Bluetooth Low Energy profile. It's actually a Bluetooth profile that's being reused in the Bluetooth Low Energy specification. So within a GATT profile, the centerpiece is a table of characteristics, which are nothing but some key value pairs. So you have a characteristic, you have a value for it. A Bluetooth Low Energy server can have 5, 6, or many characteristics. And as a client, you have the right to read them if you're connected. So before we start reading or writing characteristics, we need to set up our callbacks. Now there are 3 callbacks to set up. One is the service connected, service disconnected, and the service updated. The 2 callbacks that are most important are connected and disconnected. That lets you know when the connection is established or when the connection is disconnected. once we have our callback set up, we need to initialize the GAD functionality by calling BTWGAD init with the callback structure. And then we initiate a connection to the GAD service. To do that, we call BTWGAD connect service with the Bluetooth address and the service ID of the GAD service on the server side. And once you've done that, you just wait for the service connected callback. So it's an asynchronous call that's going to call you back when it's connected. Once you're connected, now you can get down to business. You can read the characteristics. To read the characteristics, you first get a count of how many characteristics are there for this GAD service by calling BTWGAD characteristics count with an instance handle. The instance handle is points to the Bluetooth low energy, the GAD service connection itself. Okay, so you get that in your service connected callback. So that's one handle is very important to remember for everything we do going forward. So once you get a characteristic count, you just create an array that's large enough to fit all the characteristics. And then you call BTWGAD characteristic with your instance handle, with your characteristics array. I'm calling it chars here. I know it's confusing as hell. And also with the count. And this will also return you another count telling you exactly how many characteristics were read and populated in your characteristics array. Now it's time to, now you have a handle to all the characteristics. Now it's time to read or write characteristics on the GAD table. So to read a value, you just call BTWGAD read value with the instance handle, with the characteristics you were trying to read, and a few other handles. And a few other parameters that I'm not sure what they do, but definitely documented. To write a characteristic, you just provide the instance handle as well as the value handle of the characteristics that you're trying to write, and off you go. Finally, to tear down connections, once you're done with reading and writing, you just call BTWGAD disconnect instance with your instance handle. This is going to tear down the GAD service connection. And the last step is, of course, to deinitialize the GAD module itself. Here's the interesting part, notifications. Notifications are important because it really doesn't make sense to keep calling read at a specified interval because you're just polling, right? It's not a smart thing to do unless you don't need that frequent updates. But notifications allows you to subscribe for being notified whenever a characteristics value changes. So you subscribe with the server that I want to be notified when this characteristic changes, and if it's a thermometer, if the temperature changes, the server will let you know that the characteristics has changed. Here is the value. So to do that, first thing to do is to set up a callback function. In this case, I'm calling it notification CB with your instance handle that points to the GAD service connection, and as well as a handle for the value where the notification is going to send. The next step is to register for notifications with your callback function. What that does is it registers your callback function saying this is the function you're going to call back whenever there is a notification. However, there could be multiple characteristics. What notification would you get for which characteristics is determined by the next function calls. So you have to subscribe. You have to say, I want to be notified about this specific characteristic. To do that, you call BTWGAD enable notify with your instance handle and with your characteristics object. And once you've done that, your callback function, which is already registered, will get a callback whenever that characteristic changes. You can do the same for indications, which is another concept of being notified by a Bluetooth Low Energy server. And similarly, whenever an indication happens, your callback function will get called with the value. Now, that wraps up the API discussion that we have for BlackBerry 10 when it comes to Bluetooth and Bluetooth Low Energy. But there are a whole bunch of other profiles. I wanted to just highlight them quickly, just to let you know what other Bluetooth profiles are supported on the BlackBerry 10 device. So the hands-free profile, very commonly used in car kits, headsets, in phone calls. The A2DP profile is used for outputting stereo audio or receiving stereo audio. AVRCP 1.3 is also supported. This allows a remote device to remote control a BlackBerry 10 device, its media player. So things like play, pause, previous, next all can be controlled from an AVRCP remote control. And as an AVRCP 1.3 compliant device, you can also control the volume of the remote control or the target device. It could be a stereo system right from the BlackBerry device. HID profile, also known as the Human Interface Device Profile, is also supported. This allows input devices to work with BlackBerry 10. Now we support both sides of it. You can have the BlackBerry device controlling a PC or a Playbook, or you can have a HID device, such as a keyboard or a mouse, to control the BlackBerry 10 device. Personal Area Network Profile is a new one for BlackBerry, and this basically replaces the dial-up networking profile, also known as DUN. It's much more robust. It provides full IP networking and makes it possible for the BlackBerry 10 device to work as a Wi-Fi hotspot, which is known as PAN-NAP. NAP stands for Network Access Point. So with PAN-NAP support, you can make the BlackBerry device just like a Wi-Fi hotspot over the PAN profile, so that other Bluetooth devices can connect as PAN-U, which stands for PAN-User. PAN-Use simply has the ability to connect to PAN-NAP devices or network access points. Now, the BlackBerry device also can be a PAN-U as well as a PAN-NAP. So it can connect to PAN-NAP services, or it can be a PAN-NAP itself. The phonebook access profile is mostly used by cars' head units to access the contact database of the device, so that the user, while driving, doesn't have to pull out his phone. He can view all the contact information right on the head unit of the car. The message access profile has similar use cases. In case of contacts, it's going to move over all the message database over to the car, so the user has easy access to all the messages that comes into the device. So with that, I do have a Bluetooth demo that I was working on with the Bluetooth team recently. Believe it or not, we just started on this 2 days back. Can I get a switch to the HDMI, please? And this is by no means a complete sample application. I just wanted to show you where I'm heading with this. And once it's complete, it's going to be available on GitHub, the blackberry.github.com, and you can download the full source code from there. So the stuff that I have working now, well, working last night, was you can see the paired devices right away as soon as you open the application. You can also do, okay, I just clicked that. What I'm doing here is I'm searching for devices. I hope you all have a lot of Bluetooth devices in your pockets. Hopefully all of them will show up. There you go. So we have all these devices in this room, which is discoverable, and that's why they're showing up in my device inquiry. So with the paired devices, I'm going to select my BlackBerry device. When you click on that, it's going to list all the services. And then I have plans to group them by serial port profiles and GAD profiles, so that when you click on one of those services, it's going to start a GAD reading or writing session or a notification session. Or if you select a serial port profile, it's going to start a serial port server. It's just like a chat application over a serial port profile. So you can write messages, gets over to the device, read messages, that gets sent from that device. So this is what it's going to look like. It's by no means it's complete. I still wanted to show you something that's real. It's always better to show than tell. And hopefully it'll be done by next week, end of next week. That's what I'm targeting. And can I switch back to the slides now, please? And once it's done, it's going to be available on blackberry.github.com. So for more information, please keep your eyes open for that sample, which is coming up very soon. And the documentation is available in our microsites. You can just go to developer.blackberry.com and select native SDK from there. You cannot miss the Bluetooth SDKs. So before I begin, This is unexpected, but well, they added slides to my slides. So we need to, so I'm supposed to tell you that you're supposed to join the roundtable for this session at 12 p.m. in Exhibit Hall 1. I know that, but I didn't know it was on the slides. But yeah, so at 12 p.m. in the Exhibit Hall 1, there's a roundtable, and continue the conversation on Twitter using the hashtag BBJam and the session ID Jam21 to send me or send us any concerns or questions or requests you have. And don't forget to download the Blackberry Jam America's Mobile Conference Guide and give us your reasons to believe in the video booths there. You can have your recording taken and posted on social networks or shown on at the conference here as well. And that brings us to the slide where I thank you for being here. And if you have any questions, please feel free to raise your hand. Yes?
Yes, please.
Yes, please. Sure.
So I have a couple of questions. First is on HDMI. So if there are two applications in the background that are writing to the HDMI, what's going to happen?
It's my understanding that the foreground application will get access.
Okay, but what if there are two in the background?
If there are two in the background, it would have been the most recently opened.
Or the most recently opened, okay.
That's my understanding.
Okay. And the second question is about USB. When I first looked at the session catalog, the USB seemed to be in the title, but now it's gone. I suppose it's not quite ready, but can you say something about that?
We can say that we cannot say anything about USB.
Okay. All right. Thank you.
Thanks for the question.
Excuse me, can you go back a couple slides on showing that link that, one more, yeah, thank you.
Oh, the question was about seeing the link. These slides will be available. The intent is to have them available by the end of this week.
You can ask a question from here.
The audio will be available too.
Sure.
So I have a question about the HDMI. You said we can use OpenGL and blitz stuff onto the screen. Are there any ways to use maybe Cascades or Qt to generate that user interface?
At the current time, Cascades does not talk to the second display. If you do find a way to get Qt to render to that different GL surface, then that's going to be fine. I haven't seen anyone internally try and do that though. I've compiled the Qt quick tests to make sure I could get a simple button to pop up, but I haven't personally tried to make it happen on the second screen. Conceptually, it's not very difficult, but I haven't tried.
Yes.
Okay, to repeat the question, can I display the phone screen on the Playbook screen using Bluetooth as the transport?
This is basically a Bluetooth question. So the only way I can see this happening is over a serial port profile. We don't support any profile that'll stream the screen of the Blackberry 10 to the Playbook or vice versa. But the bandwidth is limited, and you probably won't get a full motion streaming of the screen.
You wouldn't be able to get screen security stops you from doing that, unless it's your own app.
Not sure about that. If you can't get a screenshot.
Yeah, there's no API to capture a screen.
Okay. Yes.
To repeat the question, if I have a Bluetooth mouse, can I move the cursor onto a secondary screen? No. The question asker does not look happy.
Yes.
For the Bluetooth pairing, is there a way to send a pin programmatically, or does the user need to do the, the Windows intervention?
No. So the answer to that question is unfortunately no. I know there are some use cases where you might be able to, might need that. But when you call the pairing API, what happens is it's going to bring the system user experience that is consistent across the device to go through the pairing process. Now, depending on how the two devices can pair, it can be very simple as confirming some code, or it could be secure simple pairing, or it could be a manual entry of the pin. So that really depends on the two devices, what kind of pairing they support. But it's going to go through the system user experience. You cannot control what pin goes in. Yes?
Does BlackBerry 10 support Bluetooth pairing over NFC?
To repeat the question, does BlackBerry 10 support Bluetooth pairing over NFC? I'm pretty sure
The answer
it does.
is yes.
Yeah.
I thought you knew about NFC.
No,
Yeah.
It does, because I've seen
Yeah,
that.
it does support pairing over NFC, definitely. Yeah. Okay, are there any other questions that we can address before we head out to the Ask the Experts hall?
Yeah, so if there were more private questions you want to ask, that's the place for it.
Yep. All right, so with that, thank you very much. Here's our email address. Oh, not the email address. Here's our Twitter handles. But I swear I can give you my email address. I can type it right now. We're real people behind these Twitter handles, behind the email addresses. We're not just a black box that just eats your emails and never comes back. So please connect with us in any way you can. Help us help you build the best applications for BlackBerry 10. Thank you very much.
Thank you.